Welcome everyone. We're going to give it another minute or two to allow a few more people to log on. So just hang tight. We're glad you've joined us today. Okay, I think that's good. We're going to go ahead and get started. So again, welcome everyone. We're really excited to have you join us not only today, but for the next 4 weeks. This is Tom Cerati, president of SMT Supplies. We're sponsoring this free Desco Online ESD Clinic. We're expecting that you will all gain more knowledge and practical understanding of the various static control elements that you have to deal with daily in your workplace, so we are happy that you're here. Before I pass the mic to Greg Heckler, who will be taking us through this journey, a couple of house cleaning items. First off, you'll remain muted for the duration of the training, but at any time, please type in any questions into the Q&A feature. You're going to see that to your right, either in the question box or the chat box. Either way, that will work. If there are enough questions, we might even pause halfway through, but we'll certainly answer all of them at the end of the session. Each session will last for 30 minutes of training and 15 minutes for Q&A. I believe most of you know SMT Supplies. You're our customers. We're really happy that you're here, but if not, we are a key Desco distributor. We're located in South Orange County. We're also a stocking distributor for various production supply products, including solder material, hand soldering and rework equipment, chemicals, cleaners, aerosols, hand tools, inspection and magnification equipment, and of course, static control products. Our trainer for the next 4 weeks, Greg Heckler, is truly one of the experts in ESD. Greg is NARDI certified and has been with Desco for over 28 years. Greg, I'm handing the mic to you. It's all yours.
Okay. That's one thing I see the screen.
Thanks a lot, Tom. Hello, everybody. I just want to make sure that you can see our title slide here, the Desco's Part 1 ESD Basics. I'll give you a second. If you can't, either type in the chat box and let us know. Tom, can you see it okay? You might be muted.
You might have, yeah.
Okay, well, I'll open that up, Jeffrey, please, the chat. Make sure we don't have anybody that can't see.
It says yes.
Okay, we have somebody that can't.
No, they can't see.
Oh, they can't see it. Okay, good. All right, well, I'll get started then.
Okay.
Thank you for being patient. Once again, as Tom mentioned, my name is Greg Heckler. I'm the regional sales manager for Desco, and I've worked directly for Desco for over 28 years, but I've been at static control for about 39 years now. So one of the things I wanted to remind you before I begin again is that if you have any questions, technical questions or others, please type those in the questions or chat box. I also have a gentleman here, Jeffrey Brake, who's helping me with the presentation and your questions. So at the end of this presentation, it's not very long, we'll stop for questions, and then I'm going to do some demos, and you can ask questions then, but we'll make sure we get all of your questions answered. So without further ado, this presentation titled Part 1 ESD Basics. Now this is the very basics. Obviously, we can get more into depth with you at your company if you like, or via other webinar presentations, but this is going to give you the general concepts of ESD control. Hang on one second.
Why is that not wanting to beep?
There we go. Okay, so this, we're going to talk about what ESD or what is ESD, or basically how static electricity is generated and the effects. And then we're going to talk about the device models. And those are the models by which the component manufacturers measure and classify their ESD sensitive components. And then some of the basics of ESD control. Now this symbol over here on the right, that symbol, you see the black triangle there with the person's hand through it, that's our universal symbol in our business for letting you know that somewhere in your EPA or electrostatic protected area, or in a ESD packaging material of some type, something like that, that something in this area is ESD sensitive. So there really is only one symbol in our industry. It's not very complicated. So if you or your employees see this symbol, that means there's something, whether it's in a packaging material or setting on a workstation or whatever, that there's an ESD sensitive device. This might be a common label that you put on a bag or packaging material, or even if you wanted to stick to one of these on the side of your workstation. This is our universal symbol. Okay, so the way ESD, or the way static is generated, is what is called tribocharging. And tribocharging is the act of contacting and separating two surfaces. And when that happens, as an example, you walking across the carpet and picking your foot up off the carpet, or opening a plastic bag, something like that, what happens is when those surfaces separate, some of the atom electrons move. And when they move, that generates an individual polarity, which is either negative or positive. And each one of those is a static charge. So what ESD is once I have that static charge, it's the sudden flow of electricity between two electrically charged objects. So for instance, when I have a charge on my body, my hand, and I walk across the carpet and I touch that metal doorknob, what's happened is I have a charged object, that's me, and it touches another conductive object, that's the doorknob, and now I have a transfer or sudden flow of electricity between those objects, and that is an ESD event. So one of the things, a good analogy to think about is think about the metal leads of your electronic component as the doorknob. That's basically how you zap a device. You charge up your body, and then you transfer those electrons or that electricity to that device. Okay, Jeffrey? Okay, so I just mentioned this, two surfaces contacting and separating. A roll of Scotch tape is a perfect example of that. You walking across a non-ESD floor like carpet, regular tile, that type of thing. So for example, in the Scotch tape right here, when I peel that piece of tape off the roll, now those atoms, one polarity charges up one part of the tape. That's the piece I pulled off the roll, and the roll stays behind negative. And keep in mind that each one of those is an individual static charge, and each one of those polarities can cause damage to our components. One more click. Okay, so also remember that when I contact and separate two surfaces, one will always be positive and one will always be negative. Which one charges up the polarity oftentimes has to deal with what the material is made out of. So for instance, common plastics like polyethylene, polypropylene, nylons, those types of things tend to charge up positive. Other things that are more conductive, as we go from, say, plastic to metals, those tend to charge up positive. The human body tends to always charge up positive because you're walking on earth, you're walking on ground, which is already negative. So that's kind of a good way to think about that too in general. So the human body model, or what's known as HBM, is a process or a method by which the electronics industry, the component makers, simulate an ESD event created by the human body. So basically, in order for an electronic component maker to tell you how sensitive their device is, they purposely zap these components at different amounts of voltage, and then when they finally kill it, for example, they killed it at 500 volts, they classify this as an HBM class 500 volt device. In that case, it would be a class 1 500 volt device. So that's what the HBM model is. And that is you zapping the device, if you will. So you can see where the human body here is charged up positive. Again, the metal lead is like the doorknob, or it's negative. So what creates that event is, number one, opposites attract, so positive attracts negative. And number two, the component lead is conductive, and it's more conductive than you. So even though it's a tiny little IC lead or a surface mount device lead, that lead is much more conductive than your body is. So that's why the electrons transfer from you to the device. Now, the other way we zap components is what we call CDM, or charge device model. And that's the opposite of the human body model. So this one is, you should pay attention to this in particular, because most of the damage we do to our devices today is CDM damage, because just about everybody wears wrist straps now, or you might even be wearing ESD footwear on your ESD floor. So what happens with CDM is when I charge up the component and then I ground it. So for example, if I was walking around with an IC in my hand, I charge it up and I set it on a stainless steel tabletop. That's another type of damage. So that is when, again, it's when I charge up the device up, then I ground it. Other examples might be a improperly grounded pick and place machine. The head of the machine pulls the component off the tape, charges it up, and then it sets it on the pads of your circuit board. That's a CDM event. Touching a charged up device with a pair of tweezers with the tip of your soldering iron. So charged device model has become more and more prevalent because, one, devices are more sensitive, and two, most of CDM is created by what we call insulators in our environment, or things that charge up easily, like regular plastics, that by where you can induce these charges onto the component. So two types again, HBM and CDM. So the basics of control, we're going to put these in 4 squares here today for you to make it easy. Number one, the first thing we want to do is ground all conductors in our EPA or in the static sensitive area. The number one conductor is you. When you ground the body, you eliminate that or greatly minimize that HBM threat, okay? So, and also remember that ground is not temporary. I just don't go touch a metal plate on the wall and then I go to my workstation and go to work. You need to be grounded at all times, whether that's wearing your wrist strap at all times, or if you're mobile and you're standing on an ESD floor with foot grounders, you need to be grounded at all times. Other conductors may be your ESD mat, maybe shelving, carts, things like that. So the concept here is not only that when I'm grounded, I can't generate the charge, or any charge I may have on me, I dissipate it properly, but also when I ground all my conductors, now everything is negative. So if I don't have positives and negatives, I can't have ESD vent. So grounding conductors is the most important part. Okay, the second one. Now I'm going to get into a little bit, I'm going to get into ionization in depth more on another presentation and talk about insulators more, but there are things that you can't ground, and those are what we call insulators. And again, insulators are typically plastics. So if I had, for instance, a styrofoam coffee cup and I set it on my ESD work surface, it cannot be grounded because electrons won't flow across insulators. So one of the primary ways we neutralize insulators in our environment, let's say if you have a product that has a plastic case that you have to put your circuit board in, the enclosure, you would want to use ionizers to neutralize those charges. So I'll get into that a little bit more, and I'll show you a little demo of that too in a few minutes. Okay, if I cannot keep my device, my PCBA, grounded, if I have to store it, transport it, walk from one workstation to another, and I'm not grounded, I need to keep it in some type of shielding packaging. The most common is that gray metallized static shielding bag that you probably have in your environment already, or a closed conductive tote, something like that. But if the device cannot be grounded and there is a potential to induce a charge on that device, you want to make sure it's in a static shielded container. In fact, using a static shielding bag is one of the least expensive, most effective forms of static control there is. So that's why it's a great idea to use proper ESD packaging. And then lastly, it's important that you put good compliance in or have a properly managed static control program. A lot of the things of what I'm talking today and these recommendations, the standards, the requirements, all come from the ESD Association's S2020 standard. And included in that standard is also proper compliance. So periodically testing the things that you have in your static control program. It doesn't do any good to have a grounded mat if the ground falls off and it's laying on the floor when you're working there. So you really want to have a good managed program that also includes training for your employees. So you want to do some basic level of training, regular periodic compliance verification, etc. So that's another important part of static control. And the one thing I usually mention in the beginning of anything like this that I want to now is ESD control is just another form of quality control in your environment. The one challenge with a static control program is in most quality control, we can see problems. With ESD, we can't. So if you zap one of your devices, you're never going to know that until it's too late. Either the product doesn't work before it leaves your building or it comes back later. So that's why good compliance is important for ESD control. Okay, so now we're
I
gonna
don't think we have any questions.
switch to my mic. Let
Just
Jeffrey
double
check
here,
some questions.
just in case. Yeah, no questions right now.
Okay, so I'm gonna go to a few demos that I have for you.
Can we not see that? Unable to share webcam. Why is that?
Hang on, we got a little technical difficulty
Never
with the
seen that
camera.
before. No one can see you. Click to share webcam. The webcam is already in use. Please close other applications. It was working when we
Might have to
started.
shut, it might already be on, so you might have to exit out of that or
Exit out.
type in camera and turn it off.
Okay. Gotta get out of here.
Sorry, ladies and gentlemen. Can't. Actually, there we go.
Maybe.
Okay, now hang on.
It still says you can't. Please close all applications using your webcam and try again.
Interesting.
Why is it doing that?
Well, there's a first for everything. Sweet.
Not that. Yeah, I guess if I go there, can you? Let's see here.
Yeah, Jeffrey, we're good here. We see Greg.
You
Can
see, Greg?
that? Okay, good.
Okay.
All right,
All
sorry
right.
about that.
Thanks, guys.
I can't tell you how many times we practice this over and over again, and something always comes up. So you know, you probably lived the webcam life for a while, everybody. All right, so what I've got here, I got a typical workstation up. This is our marketing room, but we make a product called an ESD Survey Kit, and in this kit contains just about every type of piece of test equipment that you would need for periodic compliance verification in your EPA or all the different static control items in your process. Also for qualification, but I'm just going to show you, some basic concepts of or demonstrating what I was just talking about as far as personal grounding goes, as far as how grounding works, insulators, static generation, things like that. And for something like that, one of the primary tools that you would use for measuring static electricity is what's called a static field meter. Keep in mind that when you have a static charge on something, you can't measure that charge with, say, like a voltage meter, a multimeter. You can't just stick two probes on your skin and measure voltage. That electricity is a field emanating on top of a conductor. So you need a special piece of test equipment to measure that charge. So for those of you who don't have one of these, if you wanted to measure some of the plastics in your environment, whatever it is, you would want a static field meter. Another thing that we include in this kit are these two, we call these paddles here. We have an clear acrylic paddle, which represent what we would call either a process required insulator or a non-essential insulator. Process required is, this is the case of your product. Non-essential, it's the styrofoam coffee cup, which I would just get rid of and not use. And we also have an acrylic paddle with a solid piece of aluminum. This represents what we call an isolated or an ungrounded conductor. So the point being here is that through contact and separation, all right, we can show you, one, how charges are generated on insulators. So that right there is over 3,000 volts. Now these meters are calibrated at 1 inch. The other point here is that you can see how the farther I get, the field strength diminishes, or the closer I get. So the closer your insulator would be to your part, the more potential damage it might cause. So we can show you that you can easily measure static fields on insulators. The other thing we could show you is that you might think this is a solid piece of metal, but it's an ungrounded piece of metal, and there is over 2,000 volts on that metal paddle. Now you also probably can see to the left of the two is a minus sign. That's negative polarity, and this one is positive polarity. The phenomena is always the same, or the physics of it. No matter whether that's metal or this plastic or whatever it is, or it's two pieces of plastic, one will always be positive and one will always be negative. Now I will say this, positive charges tend to be more damaged than negative charges because the leads of your device are typically negative or metal. So that's why we're so concerned about a lot of plastics and things like that in the environment. Now the other thing I want to show you is the importance of ground in the human body. So I have a typical wrist strap here. I have it plugged into a ground jack, which probably many of you have in your own work areas. So I'm going to show you this again. I'm wearing my wrist strap, right? I still have 4,000 volts on there. I cannot ground an insulator. I stick it on my ESD mat. I'm holding it with my wrist strap. You cannot ground an insulator. So that's why I talked to you about that ionization part. So now I'm going to do this with my metal paddle. Okay, let's see if I can do this at the same time. Now watch when I touch it. Notice how it drops. I can ground conductor. So that's why I always want to keep conductors grounded at the same potential. So if this was, well, here's a good example. I got a little PCBA here. If this PCBA is sitting on my grounded mat, it's at the same potential I am, it's at the same potential the mat is, or whatever other conductors might be sitting on the work surface. So with these little tools here, it's easy, one, to demonstrate to other people, employees maybe, how this process works, but it's also easy to confirm that the products you're using are working. Here's another example of that. I'm gonna do this again. Gotta wipe my paddle off. I'm gonna charge up this. I showed you this already, but I'll do it again. I'm gonna charge up my plastic paddle to about 6,000 volts. I'm gonna take it over here. I'm gonna set it on my ESD mat. I'm gonna show you again. Can't ground it. Okay, well, didn't take the charge off. Now I'm gonna do that with my metal paddle. I'm gonna charge this one up. Now I'm not touching it with my wrist strap, okay? So I've got about 3,000 volts on that. Now I'm going to sit in on my grounded ESD mat. Now you'll see that it took the charge off. So one, that's how the phenomena of static control works, so the basics of static control, but it also can show you how things work, that I've actually validated that my mat is doing what it's supposed to do. Okay, so ionization. I've got an ionizer back here. This is a 2-fan overhead ionizer back here. So you know how I said you can't ground an insulator. So again, I put a 4,000 volts or so on that. So if this was the case of my product where I actually have to stick my circuit board in, I would want to use an ionizer to eliminate that charge from my insulators. And that, huh? Oh, sorry. Yeah, I just didn't do it fast enough, but you get an idea. There was 4,000 volts on there. Yeah. Now there's about 60 volts on there. So you can neutralize process required insulators, but you can also neutralize isolated conductors. let's say this circuit board's setting upside down on my mat. Now the leads of the board aren't touching the mat. So I would also use the ionization to keep my ungrounded conductors neutral. So again, basic concepts of static control. 1, try not to generate the charge in the first place. 2, keep my human body and all conductors at equal potential. If I have a charge, neutralize it with ionizers. If I need to take this PCBA and walk up to my office, put it in a static shielding bag, close that bag, and now it's protected. So do we have any questions, Jeffrey? Turn this off.
Let's see here. Don't have any questions. If anybody has any questions, please use the chat or the questions functions to ask those.
And if you don't, again, this training was fairly basic.
Can you, Greg? Can you show use the hood for the
Ionization?
and show the charge generated when you're not grounded versus when you are grounded? Can you do that?
I might.
Can you be able to? Can you do that?
Actually, I can't generate. I'm wearing rubber shoes here. You know what?
You can't do it.
Here, you
I might be
hold it.
able to do it.
Let me see real quick. Let me see if I can. Can you see anything now?
No, you can't. Can you not do it there? Is it hold?
Yeah.
Oh, it was on hold.
Oh, okay. Now am I getting in?
I don't know. Try.
Okay.
I'll do it.
Yeah, I can't get much. It's so humid right now. So that's another thing that's gone beyond static control a little bit, but that's why it's better using the paddles, because these are more definite. I showed you that already.
All right. Are mice and keyboards considered insulators?
Well, that's a good question. Okay, so we can talk more about that later as well, but that's what you would call either a process or non-essential insulators. There are some things that are best controlled via distance. Remember I showed you the farther I move that paddle away, the less the charge. Just keep your keyboard over here and your parts over here. So that's one of the best ways to do that. You can buy an ESD keyboard, but in my experience, you really don't need it if you're properly maintaining those types of devices at proper distances. That's a good question though.
What do ionizers do? We'll have a whole section on that.
Yeah, we're going to do that again, but you could see that the ionizer took that charge off of there. But also there is a rule to maintain conductors at less than 35 volts. So ionizers also keep conductors like the leads of the PC component neutralized also.
And then what's the rule about paper?
Okay, that's a good question. In fact, I haven't heard this one in a while. Regular copy paper, got a piece right here. Regular copy paper is wood pulp based. It's a very low static generator. Under extremely low humidity conditions, you might be able to get a couple 100 volts or something. So it's not a big static generator. Where paper is a problem is it can be an isolator. So let's say I got my work instructions here and I set my work instructions on the mat and then I set my PCBA on the paper. Now the PCBA is not grounded. So that's where you got to be careful with paper. Now if it's a plastic coated fancy piece of stationery or something, then those can generate more of a charge. But that's why it's best that if I have, say, work instructions, keep them in ESD safe shop traveler sheet protectors and not sitting bare open on your work surface.
I think at the next session, Greg, let's have an example of that, because the next session is about verifying workstations.
Okay.
So we can get an example of that paper, and then we'll do that as a verification.
And I'll show you how that's affected. That also comes into testing workstations too.
Yeah, so that'd be good for that. Somebody also asked is the effectiveness of a overhead versus a benchtop ionizer.
You want to wait till the next session on that?
Yeah, we have that in the fourth section. So why don't we'll fully discuss that. We'll have that set up. I mean, it basically comes down to coverage area.
Yeah, that's important.
Functionality is the same. It just depends on how big of an area you're trying to cover. So with an overhead, you have the advantage of gravity. Conductors versus we didn't discuss this, but can you explain what it says a dissipator, but let's just say what's the difference between conductors and dissipative, conductive versus
dissipative, right? Yeah. Conductive, dissipative. Okay, that's a really good question, and that is one of the best things about the latest ESD standard S2020. Previously, in the early 90s, early 80s, early 90s, there were many different ESD standards before S2020, and basically all those dealt with was the process of controlling static electricity. All right, and it didn't really it might differentiate between a military guy or a commercial guy. With this latest standard, S2020 was written about keeping the human body from generating more than 100 volts. It's also about controlling static electricity by how quickly we dissipate it, for instance. So I used this example earlier. If I had a charge on this PCBA, I wouldn't want to set it on a stainless steel tabletop. Zap, that's like setting it on the doorknob. Okay, so again, that doorknob analogy is a good way to think. So as devices became more and more sensitive, what we did was we started making things basically partially conductive, or what we call dissipative. So instead of this mat being 1,000 ohms, this mat is 10 million ohms. So when I set this charged PCBA on my mat, it will still dissipate the charge, but it dissipates it slow enough to eliminate the ESD event. So when we're concerned about conductors versus things that are dissipative, what we're really concerned about is how fast we want to get rid of the charge. When I ground the human body, I want to get rid of that charge immediately. When I ground the device, I want to do it fairly slowly. So the good analogy for that is if the PCBA or the ESD device is going to touch it, in almost all cases, it should be dissipative. So that's a good question.
I think next week too, we'll measure some different surfaces, and we'll be able to show what's dissipative and what's conductive.
Exactly.
Right. So get a better idea of that.
And we do that through what the resistance.
Because that's all part of verifying a workstation. So that would make sense then. It looks like that's the end of the questions for now.
Okay. Well, those are all good questions, and one of the reasons they're good questions is they are things you should know, but they also help you build a good static control program. When you understand, what's the best horse for the course? What's the best type of mat? An overhead versus a benchtop, how it works and what's the best one for my environment. So that's what we're going to deal more in the next 3 sessions.
Yeah.
So if nobody has anything else, I'm going to throw it back to Tom, and thank you, everybody.
Yeah, well done, Greg and Jeffrey. We appreciate it. And those that don't or who are not aware, Jeffrey Brake, or we can see partially there. Why don't you stand up, Jeffrey, is the Desco brand manager. There we go. All right, good. So both really well done. We appreciate it. And just a good segue into what's coming up in the next 3 weeks. Like they've mentioned, next week is going to be how to set up and verify an ESD state workstation. The following week, continuous monitors and EPA access control. And then we're going to conclude with process essential insulators. Greg touched on some of that today. Isolated conductors and ionization. And we got a little foretaste on that today. So all really good stuff. We hope you found this first session to be beneficial. Okay, so we've got an announcement. We want you to all know that SMT Supplies is going to be conducting 2 promotions at the end of the 4 weeks. First one will be a 10% discount coupon for a single purchase of anything on our website, with a couple of exceptions like bar solder because of pricing today. But the second one, your names could be entered into a drawing to win the new Desco dual operator single wire continuous monitor. It just got released a little while ago. It's valued at $235. But to take advantage of both, you need to attend all 4 sessions. So we really encourage you to do that. that's it. We're done. We appreciate it. Thanks for joining, and we will see you all next week, the 14th at 11:15 a.m. Pacific Standard Time. Thanks, everyone.
Thanks, Tom.
Thank
Thanks,
you.
guys.
Bye.
Thanks, everybody, for joining us. Have a good
Bye-bye.
day.